We are honored to have the opportunity to present our work entitled Dual-Band Aperture-Shared Filtering Reconfigurable Intelligent Surfaces. Reconfigurable Intelligent Surfaces, RISs, have been regarded as a critical technology for 6G wireless communications. However, single-band RISs only regulate a band signal, resulting in low aperture utilization. Moreover, most of the RISs lack frequency selectivity, out-of-band signals and interference are regulated. To address those challenges, we have designed the Aperture-Shared Filtering RIS to improve the aperture utilization and manage electromagnetic spectrum. Inspired by aperture-shared antenna arrays, aperture-shared schemes are divided into three types. First, the lower and higher band subarrays are arranged side by side. The mutual coupling between them is slight. However, its aperture utilization is low. Second, the lower and higher band elements are spatially staggered arranged to improve the aperture utilization. However, the blocking interference between them is severe. Finally, the lower and higher band elements are coplanar embedded to eliminate blocking interference. The aperture utilization is highest. An aperture-shared RIS is designed according to the embedded scheme. First, a split ring and a polygonal patch are employed as the lower and higher elements, respectively. Second, the polygonal patch with the horizontal slots is embedded into the split ring. Finally, a pair of vertical slots is added to the polygonal patch to extend bandwidth. The independent phase shifts in dual working bands have been realized. To suppress the out-of-band interference, a filtering layer is designed. The in-band electric field is distributed as a standing wave state, showing that the incident signals are fully reflected. Instead, the out-of-band electric field is distributed as a traveling wave. Out-of-band signals are eliminated. Placing the filtering layer on the aperture-shared element, favorable out-of-band suppression are realized. For further validation, a dual-band aperture-shared filtering RIS has been fabricated and measured. The dual-band filtering gain response curves is achieved. The operating bands cover the N79 and N104 bands, and the out-of-band suppression levels are less than -13 dB. Furthermore, the main beams can be scanned to 60 degrees in two operating bands. To investigate the dual-band independent operation, the radiation patterns are presented as in-band beams is set differently. When the main beams in one working band are changed, the radiation patterns in another operating band remain stable. Additionally, all radiation patterns outside the working band are suppressed.